Have you ever looked up at those massive steel transmission towers marching across the countryside? If you have, you've probably noticed those strange dangling chains holding up the power lines. They look like stacks of ceramic plates, or maybe even tiny glass UFOs. But why do they look like that? Why not just use a simple solid rod of glass to hold the wire? Welcome to Simple Things Surprising Histories. Today, we're looking up at the sky to answer a fascinating question. Why do power line insulators have so many disks? To understand the shape of these disks, we first need to know what they're fighting against. The power lines overhead aren't carrying the standard voltage you use to charge your phone. They're carrying hundreds of thousands of volts. At those extreme levels, electricity is desperate to find the fastest path to the ground, and those giant metal towers are the perfect shortcut. If a live wire even comes too close to the tower, electricity will literally jump through the air in a blinding flash of plasma called an arc. To prevent this, engineers use insulators, materials like glass, porcelain, and modern polymers that electricity struggles to flow through. But a material's natural resistance isn't enough on its own, because in the real world, things get dirty and things get wet. Imagine if we just used a simple, smooth cylinder of glass to hang the wire. On a beautiful, dry day, it would work perfectly. But what happens when it rains? Water coats the outside of the smooth cylinder, creating a liquid bridge. Dust and pollution mix with the water, making it conductive. Suddenly, that massive voltage has a wet highway straight to the metal tower, causing a catastrophic short circuit. This is where the brilliant disc shape comes in. Each disc acts like a tiny umbrella. When it rains, the top of the disc gets wet, but the grooved underside remains completely dry. This dry space acts like a roadblock, breaking the wet highway and trapping the electricity. This shape also creates something engineers call creepage distance. Electricity traveling along a surface has to follow every single curve, ridge, and groove. By stacking disks, engineers take a distance of just a few feet and fold it into a surface path that is several times longer. It forces the electricity to run an exhausting marathon just to get to the tower. This ingenious design hasn't always been around. In the early days of electricity, engineers used simple, rigid, pin-style insulators. But as cities grew, power had to be transmitted over longer distances, which meant drastically increasing the voltage. The old single-piece designs kept failing. Then, in 1907, engineers Harold Buck and Edward Hewitt invented the modular suspension insulator. This changed everything. It meant engineers could finally customize the insulator for any voltage. Need to support a smaller 11,000-volt line? One or two discs will do the trick. Building a massive 400,000-volt line? Just link 20 discs like a chain. And if a severe storm rolls in and a lightning strike shatters one of the discs, repair crews don't have to replace the whole assembly. They just swap out the broken disc. It's the ultimate plug-and-play system, suspended hundreds of feet in the air. So the next time you're on a road trip and you see those towers marching toward the horizon, take a close look at those dangling discs. They aren't just random shapes. They are perfectly engineered umbrellas, folding space and blocking electricity to keep your lights on. Sometimes, the most complex problems are solved by the simplest shapes. If you enjoyed this journey into the hidden history of our everyday world, please hit that like button, share this video with a curious friend, and subscribe to Simple Things Surprising Histories for more. Until next time, keep looking up.